this session, we will focus on the use of Excel to perform analysis associated with the normal distribution. This is going to be a busy session, and I hope as you review this session, you will have your Excel running simultaneously so that you can apply what we will cover in this session every step in the way, because that will help a great deal being able to perform this analysis. And later on, the more you practice, the better you will get at it. So let's go ahead and start with this session. Using Microsoft Excel to find the area under the normal distribution curve. We see how easy it is to find the area under the curve. But in case you don't have a normal table accessible, then you can use Excel functions to do that. For example, determine the area to the left, that's the cumulative area of a certain value of x, say 109, in a normal distribution with a mean value of 88 and the standard deviation of 12. Well, we know about the Excel function. We can click on this function here, and that will give us this menu here, and we can click on statistical so that we can perform statistical functions. And the key here is to go to the normal distribution menu. That is this menu here, Norm Dist, that normal distribution. But as you do that, you have to keep in mind what you are trying to do. We have a distribution that has a mean value of 88 and a standard deviation of 12. And we are interested in a value of x of 109. So when you click OK here, what we're going to get is this menu here. Now here is the x value, 109. Here is the mean value of 88. And here is the standard deviation of 12. Now when we say true, true here means versus false, as we discussed before. It simply means the cumulative area from minus infinity to the z value corresponding to the 109. Now Excel is not going to give you the z value because it will do this transformation for you in the background. It will only give you the area. So it will save you from doing the calculations. I prefer myself to perform this type of analysis manually, but if you need to use the normal curve, the Excel spreadsheet, given the fact that you don't have the table, then this is the easiest way to do it. We now can move to a more important application of the Excel spreadsheet, and that is simulating a whole population using a normal distribution. That is simulating a variable associated with a population using the normal distribution. Previously, when we discussed the probability distributions for discrete variables, we showed you how to do that using the random number generated functions or tools in Excel. We will use the same tools now, so hopefully you are a little bit familiar with what we will discuss. So let's go to the slides and see how we do that. In fact, we're also going to do it in Excel to show you how simple and easy it is. All right, what we have here is we need to use Excel to generate a distribution. That's a probability distribution. So let's take an example. The total sales revenue per week of a company follows a normal distribution with a mean value of 100,000 and a standard deviation of 15,000. And the question is generate a normal distribution for this sales revenues per week using Excel data analysis. Let me go over the analysis in the slideshow first before we go to Excel. You keep in mind that your mu is 100,000 and your sigma is 15,000. So we're going to go to data, and from data we're going to go to data analysis. And in data analysis you're going to go to the random number generation as we did before. And in the random number generation you will have this menu here. We have the number of variables. We're dealing with one, which is the sales revenue. Hopefully you have prepared a cell or a label called sales revenue. And then here is the number of random numbers we're going to generate, 1,000. And then you will select the normal distribution. Previously, we selected the binomial, which prompted us to the parameters of the binomial, the p and n, or we selected the Poisson, which prompted us to the parameter of the Poisson, which was lambda, if you remember. Now that we are selecting the normal distribution, it will prompt us to the parameters of the normal distribution. That is the mean value and the standard deviation. And once we do that, we click output or assign an output. And here we go. We can actually generate random numbers of the entire population or 1,000 of the population. As you can see here, here are different values of sales values generated using the random number generation. Of course, the column goes all the way down to 1,000, but it's only showing a small part here. And now we can perform descriptive statistics in the data using the descriptive statistics analysis tools. Here is the input range, which is the entire column. We can assign an output, we can do summary statistics, and we can click OK, and that will give us the descriptive statistics. Here is the mean value of the revenue, here is the median, the mode, the minimum, the maximum, and so on. Notice that the mean value is close to the $100,000, which we specified as our average of this population when we generated the normal distribution. And if we have that, we can create a bin range, and from the bin range we can create a histogram or a distribution of the sales revenue. Let me now go to Excel and do that step by step. Here is the Excel spreadsheet, and we're going to talk. Let me just remind myself of the values. We have a mean value of 100,000, and we have standard deviation of 15. I think it was 15,000. So this value here should actually be 15,000. Very good. So these are the two parameters that we need in order to generate the sales value data. So let's go here and put a label. We're going to call it sales revenue. Okay, and we now can go to data, data analysis, random number generation. We click OK, and as we did in the slides, we're going to use one variable, which is the sales revenue. That's the one that I prepared and titled for here. And let us generate, say, 1,000 values of sales revenues. And since we selected a normal distribution, we will have to put the mean and the standard deviation given. Our mean value is 100,000, and our standard deviation is 15,000. So we have a mean value of 100,000 and the standard deviation of 15,000. And that's all what we have to do. Then we can specify an output. We can click on here and anchor it by clicking again here and go under here. So the values that we will generate will all be under this title here. That's all what we have to do. Now, I want to point out something. You have here a random seed window. And what does that mean? If you ever want to use the same data that you generated once, you can have an ID or a seed number here that will allow you to reproduce the same data again. That's if you have to. We will not do that in here. We simply used one variable, 1,000 random numbers generated, a normal distribution. We inserted the parameters of the distribution mu and sigma, and we specified an output, and we say OK, and we have now 1,000 values of the sales revenue data that we just generated. As you can see here, we can go down the column all the way to a 1000 values. In fact, it goes all the way to cell 1006, given the 1000 observations. So in a fraction of a second, we were able to generate 1000 values of sales revenue. And if we don't like the too many decimals, you can click on the right bottom of the mouse to format cells, and you can go to number, and you can control the number of decimal places here. Since these are in the hundreds of thousands of orders, we may want to get rid of any decimals, and now we have values that are without decimals. These are the 1000 values of sales revenue. Now, are these values accurate? Of course they are. However, they are as accurate as the parameters that we are given. If these parameters are inaccurate, then these values will definitely be not accurate. So you want to make sure before you generate random numbers that the parameters that you are using, in this case the mean and the standard deviation, are accurate. So now, all of a sudden, we have 1000 observations that did not exist a minute ago via the random number generation. And what does that mean? It means we can do any type of analysis with it. We can do descriptive statistics, for example. I can go to descriptive statistics in the data analysis tools, click OK, and now I have the cell going from H5 all the way to H1006. This is, or I can actually block all of these with the mouse to obtain the input range. I have labels in the first cell. I can put the output somewhere in here, and I can use summary statistics, and I can say OK. And now let me just go over this again. I can block all the input values, as you can see here, the 1000 values, and that will be my input range. And I can have my output somewhere, summary statistics, and we say OK. And now we have our descriptive statistics of the generated data of sales revenue. And as you can see here, again, if we want to get rid of the decimals, we can use 1 decimals or less. And we now have a mean value that we can see. We have a range that we can see. We have a minimum and a maximum. And we have the median and the standard deviation. Notice something here, that if you observe the mean value and the median and the mode, you will see that these 3 values are more or less the same. Keep in mind we're generating random numbers here. So they are not going to be exactly identical, but they are very close. And that's a good indication that what we are actually generating is a normal distribution, because in a normal distribution, the mean, the median, and the mode will be the same. Okay? Also notice that our standard deviation is about 15,000. It's 15,268. And keep in mind that that was one of the 2 parameters that we have to insert in the Excel data analysis. So the mean was satisfied as almost 100,000, and the standard deviation was satisfied, and we should not be surprised because that is how we generated the data. Now we have the descriptive statistics. I can go to bin range, and I can develop a histogram. Now notice we're starting here a minimum value of 54,427, a maximum value of 144. So I can start a little bit lower than the minimum at 50,000, and I can move on. If this is a sales revenue, then perhaps I want to go at 5,000 or 10,000 interval. So if I say plus and I go up and add 5,000, that will give me an interval of 5. And now I can copy this and go down, paste the calculations all the way. I have here 105. I still need to go further down, all the way to 155. I really need only to 145. So I can delete this and delete this. And what I just created is a bin range in order to construct a histogram. That bin range begin at 50,000. it goes all the way to 145,000. Notice that the minimum value was 54, so I started a little bit lower than the minimum. And the maximum value was 143, so I ended up a little bit higher than the maximum. And now I have included all my data. I can now go to data analysis, histogram. Okay, our input range will be all the data that we generated, which is the sales revenue data. So we're going to do the same thing that we did with this descriptive statistics, input in all the data that we generated. Our bin range will be the bin range we pre-constructed. As you can see here, I'm going to go to the bin range, and I'm going to give this column to Excel. So now Excel have the input range and they have the bin range. There are labels in both the bin range first row and the data first row. Then my output, I normally put it next to the bin range just to make sure that we did it correctly. So I'm going to put it here, and we're going to do cumulative curve and output, chart output, and we say okay. And what does that mean? It means we now have the normal distribution that we have created. And as you can see here, that didn't take much time. And of course, we can separate the cumulative from the normal distribution from the actual histogram by copying this, pasting it here. So now I have two copies. I can go in the top copy and delete the cumulative curve, and I can go in the bottom copy and delete the histogram. And now I have a cumulative curve in one case and the histogram in the other. If you don't like those gaps, then we can easily come here and click on the right button by clicking on the series and just say close the gap or no gaps. And now we have a nice distribution that is continuous and it has no gaps. We can also change the color if we want. I mean, we can click on the series, then click on the right button, go to format data series. We can do the fill, solid fill yellow. We can also make the border color black. And now we have a nice distribution. Now keep in mind that this is a histogram. We want this histogram to be a probability curve. So let me go over this for just a few seconds. I need to convert this histogram into a probability distribution. Now if you go back to the frequency table developed or constructed by Excel, what we have here is the bin, and what we have here is the frequency. Now what I need to do to convert this into a probability distribution is to convert the frequency into relative frequency. And how we do that? Well, we're going to come here and we're going to add a column called relative frequency. Really, it is the probability, because as we mentioned in the sessions, probability is basically the relative frequency. And now we need each frequency to be divided by the total frequency in order to get a relative frequency. Notice, if I get the sum of all of these, this is equal sum, and I go up here, this sum is better be the 1,000 observation that we constructed. Remember, we generated 1,000 observation. So the sum of all the frequencies is 1,000. So now if I want to convert any frequency into a relative frequency, such as this one here or this one, I'm going to come here and press equal and go all the way to frequency and do a slash, which is a division, and divide that frequency by 1,000. Here again, I can go to the next cell, equal, move to frequency, slash, and divide this by 1,000. I don't actually have to do that for each observation, because I can copy the calculation and go down and paste it, and that will repeat the calculations for all the cells or all the frequencies, as you can see here. So what I just did, simply I created a relative frequency column or a probability column. Notice also that if I get the sum of this column here by coming here and say equal sum, open a parentheses, and go up and add up all of these values of probability, this sum is better be 1. And as you can see, the sum of probability is 1, just like the sum of all the observations was 1,000. Now that I have a probability column, I can easily copy this. I can block this column, as you can see here with the mouse, and copy. And I can go in my graph and click on the graph and right button and paste. Now, you will not see anything, as you can see here, because the two distributions superimposed or coincided. So how we do that, how we create a probability distribution, now that I have, if you notice, two series here, one for the frequency and one for the relative frequency or the probability, I can easily delete the histogram or the frequency. If I click on the histogram, click on the right button and delete, what I see now is a true probability distribution. In fact, if you look at the values here, you will see that these values in the vertical axis are actually not frequencies, but rather probability. I can come here and change this column into Px or probability. I can remove this or change it from histogram to probability distribution of sales revenue. And I can even delete the series because I know now what is this. This is sales revenue. I can change the bin range and title it sales revenue because that's the actual meaning of these values here. And I can also alter the series color. I can make this yellow just to make it more customized. I can make the border different colors. This is the border color. I'm going to make it black. The fill, I'm going to make it yellow. And now we have a nice looking probability distribution. If you don't like the more, by the way, you can always come here in the frequency table and simply erase more. If you delete more, you will not see more in the probability distribution or the histogram. And what's good about that now is in a few seconds we were able to construct a normal distribution that follow the parameters we did. I can then add comments here, or I can observe and examine and describe the distribution that I have, or obtain many informations as we discussed before. The point I want to make here is what we just did is essentially a histogram, but it is in the form of a probability distribution. It has classes of values, it has constant interval, it has a vertical axis that we called it probability or relative frequency. And if you go back to the sessions where we were able to obtain lots of information from the histogram and from the cumulative frequency curve, you can apply the same concepts that you learned in the previous session of histograms and the cumulative frequency distribution on the probability distribution concepts. So the idea here is how to simulate a population. We started out with two values, the average of the population of sales revenues and the standard deviation. And if we can do that, then we can generate a whole population, 1,000 observations. That's 1,000 random values of sales revenues. And to me, that's really amazing that you can simulate a whole population this way. And these values are accurate. They are as accurate as the parameters that you are inserting. If your mu and sigma are accurate, then the generated random numbers will be accurate. And you can use these numbers into descriptive statistics, histograms, probability curve, probability distributions, and obtain any information that you need. Thank you.